Welcome to Crystal Clear Chemistry channel. In order to crack either JEE mains or NEET exam, let's strengthen the basics of chemistry through this channel. In this video, I am going to discuss about the part 3 of ionic equilibrium, in which we are going to focus more on the pH scale, Ka, Kb and Kw calculations and all, especially to calculate the pH values. Many of you are having may have the confusion to calculate the H plus ion concentration. So there are different cases in which we need to take a H plus ion concentration for by using different formulae. That and all I am going to discuss in this video. Okay, so definitely helpful for you if you have a doubt in calculating the pH. Let's get into the topic now. If we consider the conjugate acid base pair. What is conjugate acid base pair? The pair which differ by a proton. H plus is nothing but conjugate acid base pair. Right? Now, what is ionic product of water? Ionic product of water is nothing but H plus ion concentration into OH minus ion concentration. This and all we discuss in the second part, right? Anyhow, if we consider the Ka for an acid, if Ka is the dissociation constant for an acid, if we take the conjugate base of it, and if Kb is the conjugate, that dissociation constant of that conjugate base, then if we take the product of Ka and Kb, that will be equal to Kw, which is nothing but 10 to the power of minus 14 at 25 degrees centigrade or 298 Kelvin. If we apply the negative logarithm on both sides, you will get a new equation that is nothing but pKa is plus pKb is equal to 14. What is pKa? Negative logarithm of Ka. What is pKb? Negative logarithm of Kb. And what is pKw? It is nothing but the negative logarithm of Kw, right? Anyhow, we came to know a new formula here, that is nothing but pKa plus pKb is equal to 14, right? Next, if we consider two acids and if their dissociation constants are Ka1 and Ka2, then how to compare their acidic strength? Let us see. Degree of dissociation alpha 1 we know, and let us suppose that the degree of dissociation for the second acid is alpha 2. Alpha means square root of Ka1 by C. Alpha 2 means square root of Ka2 by C. If the concentrations are same, then we can compare the two acids strength, where the C terms gets cancelled out and you will get the expression as the square root of Ka1 by Ka2. So with the help of this formula alpha 1 by alpha 2, you can calculate the relative strength of two acids. If they are bases, it is nothing but square root of Kb1 by Kb2, right? And did you remember the expression for Ka here? Expression for Ka is nothing but C alpha square by 1 minus alpha, right? And from this expression, we derived lot of formulae like H plus ion concentration is equal to C alpha and all in the part 1, in the part 2, right? Here, one important note point is, if that alpha degree of dissociation is uh, more than 10 power minus 3, then definitely alpha cannot be neglected. Then 1 minus alpha is not equal to 1. In that case, the full expression Ka is equal to C alpha square by 1 minus alpha need to be taken to calculate the Ka value. Okay. Now let's get into the main topic of this part, that is nothing but the pH scale. Why? First of all, what is meant by pH? Means pH is nothing but the negative logarithm of H plus ion concentration. Suppose if we consider H plus ion concentrations of weak acids, generally they are with the decimal values. For example, if we consider the H plus ion concentration of CH3COOH at a particular in a particular solution, it will be around 5.8 into 10 to the power of minus 5. So every time to express the concentration with these decimal values and these 10 powers and all, it's very difficult for the calculations and all. And hence the scientist Sorensen introduced the term pH to simplify the concentration of H plus ion concentration. Okay. He simplified by applying the negative logarithm. Okay. Before going to check how to calculate pH and all, let us see the importance of pH here. If the acid is having tendency to give H plus ions more is the acidic character. If it gives more H plus ions, if we apply the negative value for negative sign for the larger value, then pH will be less. So what is the conclusion? Strong acids have less pH. Strong acids have less pH, and similarly if we consider instead of acids, if we consider bases, we can even calculate pOH for bases. And if we apply again the negative logarithm for OH minus ion, the strong acids give more OH minus ions. More is the value. For more value, if we apply the negative sign, you will get the less value. That means pOH will be less for basic solution. For basic solution. Then let us see who introduced and what is pH exactly. Uh, the concentration of H plus ions can be simplified with the help of pH scale, which was introduced by Sorensen. It is a negative logarithm of activity of H plus ion, or you can say activity is nothing but the concentration. That means the the part of the sub ion which is involving in a reaction is nothing but active mass or concentration or activity. All these three terms are similar. What are those three terms? Activity, active mass or concentration. Nothing but the amount that is utilizing in the reaction. That amount that is actively participating in the reaction. Anyhow, come back to this pH case. pH is equal to minus log H plus ion concentration. Right? Now, if we consider at 25 degrees centigrade, the pH will be ranging from 0 to 14, where the central point is 7. Of course, you know already that pH is equal to 7 for the neutral solutions. Right? pH will be less than 7 for acidic solution, and pH will be greater than 7 for basic solutions. Right? We have a general idea about this pH scale. Now let us see why that 14 came, how that 14 came. Is it 14 always? Is the scale always from 0 to 14? No. Let us see why it is. At 25 degrees centigrade, we came to know the H plus ion concentration into OH minus ion concentration is 10 power minus 14. That's how the pH scale is fixed from 0 to 14 at 25 degrees centigrade. If it is not at 25 degrees centigrade, if it is raised, if the temperature is raised, temperature of the solution is raised to 80 degrees centigrade, or the water if we rise to 80 degrees centigrade, more number of water molecules are dissociated, more is the concentration, and it will be this time 10 power minus 13. In that case, the pH scale range is from 0 to 13 and the neutral point is 6.5. So, the conclusion here is the pH is not fixed. it is depending upon the Kw. In turn, the Kw is depending upon the temperature. That means pH can be any greater than 14 also, it can be negative also, always depends upon the temperature of that particular solution, water, aqueous solution or water. Okay, that is all about the fundamental concept of pH. Now, before going to check how to calculate and all, let us see the pHs of some of the substances. Okay, distilled water, if we consider, it is around 7. If we consider the lemon juice and all, it is in between 1 to 3. If we consider the soap solution, which is alkaline in nature or basic in nature, the pH value is about 10 to 11, right? And in fact, if the pH is in between 7 to 11, it is a weak base. If the pH value is 11 to 14, we can say it is a strong base. Similarly, if the pH is around 4 to 7, we can say it is a weak acid. And from 0 to 4, if we consider the pH, the strong acids have the pH values in between 0 to 4, right? Important. Now, let us see what is the pOH exactly. Just like pH, the pOH is nothing but the negative logarithm of OH minus. This we already discussed, right? Now, suppose if we consider the sum of pH and pOH, as we know already it is equal to pKw, that pKw value is 14 at 25 degrees centigrade, and hence acidic solutions pH less than 7, basic solutions pH greater than 7, and vice versa for pOH, right? Now listen carefully. The important concept of today's video we are going to discuss, that is the pH calculation of different types of solutions. First type, if the concentration of the strong acid solution is greater than 10 power minus 6, then how to take the H plus ion concentration? Listen carefully. Here what we are going to discuss, we are going to discuss how to calculate the H plus ion concentration. Why we need to calculate H plus ion? Because we want to calculate the pH, we want to apply the negative logarithm for that H plus ion. Then how to calculate, if they don't directly give H plus ion concentration, for different solutions, how to take H plus ion concentration, let us see. Okay. Now, for a strong acid solution, if the H plus ion concentration is, if the acid solution is concentration is greater than 10 power minus 6, that means let us say normality is 10 power minus 6 normal solution, not minus 6. If it is greater than 10 power minus 6, right? So let me take a 5 now. Okay, n is equal to 10 to the power of minus 5 normal solution. Then H plus ion concentration is nothing but the normality of the solution itself. That means for the solution of 10 power minus 5 normal solution, H plus ion concentration is equal to 10 to the power of minus 5. pH, if we want to apply, it is nothing but minus log 10 to the power of minus 5, log a power n log a, minus 5 into minus 1, 5 log 10 value 1. So the answer is 5 here for the pH, right? This is the first case where the acid solution concentration is greater than 10 power minus 6. If it is less than 10 power minus 6, let us see. If it is less than 10 power minus 6, that means let's consider again the example here. If it is less than 10 power minus 6 means if the normality of a acidic solution is 10 power minus 8 normal, it is definitely the less than that of 10 power minus 6, then we can't take H plus ion concentration as 10 power minus 8. It's not, the H plus ion concentration is not 10 power minus 8. Why? Because the water itself contains H plus ion concentration as 10 power minus 7, which is greater than 10 power minus 8. So if the solution concentration itself is very less, and even if it is less than the H plus ion concentration from the water, then in that case the H plus ion concentration from the water cannot be neglected. Then total H plus ion concentration will be how much? It will be 10 power minus 7 plus 10 power minus 8 from the solution and from the water. Then how to calculate the pH here? Let us see. Take 10 power minus 7 common and you will get 1 here, plus here you will get 0.1. So 1.1 into 10 to the power of minus 7. If we want to calculate the pH, you have to apply the negative logarithm minus log H plus ion concentration. Okay. Let me take another slide here, because as it is very important, I want to write clearly. Yes. Yes. So we came to know that the H plus ion concentration is 1.1 into 10 to the power of minus 7, because we took the H plus ion concentrations even from the water, right? So apply the negative logarithm for this, minus log H plus ion concentration minus log 1.1 into 10 to the power of minus 7. Log 1.1 is around 0.04. Log 1.1 value is approximately 0.04. Thereby you can get the pH value as 6.96 for the solution. What is the conclusion? The conclusion here is, if we consider the acid, if its normality is 10 power minus 8 normal, then pH is not equal to 8. In fact, the pH is 6.96. If pH is 6.96, pOH will be 7.04. The same you can apply even for the base. For base, if 10 power minus 8 is the concentration, pOH will not be equal to 8, then pOH will be, again we calculate, again we take the OH minus ion concentration from the water, and in that case pOH will be 6.96, whereas pH is 7.04. So very important. All these two uh, lines are very important, from especially in entrance point of view. Hope you understand it well. Now let's move to the next case. Suppose if they ask us to calculate the pH of the mixture of solutions. If we take two strong acids and if we mix them, then what will be the resultant concentration? In the concentration topic, we know already the resultant concentration. If the solutions are having the same nature, the resultant will be the addition of those moles, right? So the resultant normality n into v, resultant equivalents are nothing but n1v1 plus n2v2. In that case, the H plus ion concentration will be n1v1 plus n2v2 by v1 plus v2. So whenever they are asking us to calculate the pH, to calculate pH, we need to calculate H plus. H plus ion concentration can be calculated by using this formula, where the N1V1 and N2V2 are the number of equivalents of two different acids. It is true even in the case of base also. If we add two strong bases and if we want to calculate the resultant base pH, first we need to calculate the OH minus ion. As they are the bases, directly we can get the OH minus ion concentration. The resultant normality will be the OH minus ion concentration. The resultant normality will be the OH minus ion concentration. Thereby we can calculate the H plus ion concentration by using the formula H plus ion concentration is equal to 10 to the power of minus 14 divided by OH minus ion concentration. Right? Now, what will happen if we add acid and base together here? If we add acid and base together, then the one which is having more concentration will remain at the end in the solution and the lesser part will neutralize. That means if we add acid and base together, if the concentration of acid is more, then the completely the base basic part will be neutralized and the leftover H plus ions leftover H plus ion concentration you can calculate by using the formula N1V1 minus N2V2 by V1 plus V2, and the solution will be acidic in nature. If acid and bases are mixing together, if the base concentration is high, then the acid completely neutralizes out. Because of the leftover OH minus ions, the solution becomes basic in nature and the leftover OH minus ion concentration can be calculated by using the formula N1V1 minus N2V2 by V1 plus V2, and from that H plus ion concentration can be calculated by using the formula 10 power minus 14 divided by OH minus ion concentration. Understand? So this is how to take different formulae in order to calculate the H plus ion concentration or OH minus ion concentration. Thereby simply by applying the negative logarithm to them, you can calculate either pH or pOH. Right? If you really like the video, please like, share and comment below. Thank you one and all. In the next video, we are going to discuss the very important topic of buffer solutions and salt hydrolysis. Okay, stay tuned. Thank you.